we'll go into it. Okay, so Vidi, you're leading the session today. We have a set of questions that we prepared to engage with Mr. Slawek. So let's go ahead and kick it off. Vidi, over to you.
Yeah, right. Thank you very much, Mr. Cheng. So yeah, Mr. Sławek, I believe all of us have read a lot of the articles that you've written, and I'm really interested in your research. But actually, first I would like to ask a little bit of question about the thought process in going through the M4. So from my understanding is that from M1 to M3, they've established that contemporary machine learning methods like non-neural networks actually perform better than neural networks. So what brought you to the decision that you'll try out the compound between non-neural network method along with neural network method in your entry in M4 competition, Mr. Sławek?
Yeah, so the story was that, I started doing forecasting when I was in Microsoft, so like 7 years ago. And after trying this sort of standard methods like exponential smoothing, ARIMA, I found them, insufficient because I was in Azure. And Azure, at least at that stage, was growing definitely faster than linear, although not exponential. I was close to it, sort of in between, And there was no method I could find which would provide trend, which is non-linear, but sort of in between. And then I discovered a program called STAN. So this is probabilistic programming language, which allows you to write model in their own language, but it's pretty simple, kind of mix between C++ and R. And so you write your model in this language, and then you have kind of two engines, either approximate Bayesians or Monte Carlo. I was using Monte Carlo because it's more correct, although slow, right? And that worked pretty well. I got nice nonlinear models working pretty well. Extension of Holt-Winters methods. And then at some stage, but it works great. It is nice model, but the primary problem was time, right? One time series, maybe 10 minutes or something like that. So if you have hundreds, thousands of time series, that is impractical. So I started playing with, I wrote my first neural network stuff, I don't know, 20 years ago or something. So I kind of started playing with neural networks again. And the results were mixed. Occasionally I was able to be better, but usually not, than the standard algorithm. They're surely worse than the stand-based algorithm. By the way, if you want to look at the stand-based algorithms, there is a package called RLGB, and then should be local global trend model. So it will be RLGT, local global trend model, RLGT. So there is a package like that, which I sort of done last year. But this is really work I did in Microsoft. So it was usually better than neural networks. And I was trying neural networks again and again because I wanted to get the speed. And pretty much I wasn't very successful. But then I think it was second half of 2017. I learned about this dynamic computational graph neural networks, DyNet and PyTorch. And then I realized that they, using them, you can do stuff almost as in STAN. I can write my own function. I can do a lot. I can do coding. So when I realized that I brought some ideas from my STAN programs and coded them in neural network, and then it worked. So my 3 years quest to get neural network performing better than standard algorithm actually got fruition in December 2017, nicely 1 month before M4 started. So I was quite lucky, in this respect. And then I applied that thing and worked quite well. Yeah. So yeah, from exponential smoothing to STAM, my own models, to dynamic graph computational neural network, and eventually there was this M4 model. Yeah.
I see, I see. So, so you're using stacking, right, in the model. You combine two different models to create a unified model that could perform better, which is the
It's as I said, if in dynamic graph computational neural network now, pretty much all of them are like that. I mean, there is PyTorch does it, of course. Dynet is nice but dying. No one develops this project, so I wouldn't advise you to do that. But PyTorch definitely, and TensorFlow version 2 also, right?
Yep.
Version 2 onwards. So they all can be programmed kind of like normal imperative ways. So you can do really a lot of stuff by programming. If you think about neural network, what neural network is some sort of multiplication of vector multiplied by array plus something, and then some nonlinearity, right? And that mechanism repeats itself. So really, neural network is nothing special. It's just subset of operations. It means matrix of multiplied by vector plus something plus nonlinearity. So the point is this dynamic computational graph system allows you to do that. And the neural network is nothing special. It's just one of the operations allowed because AutoGrad allows that and some other stuff. You have a limited set of operations, but they are pretty broad. So the point is, if you write neural network, you actually don't do anything special. And if you don't do anything special, you can do something extra. You can do pre-processing on the fly. You can do some stuff. And these parameters of pre-processing can be fitted by gradient descent too. You specify some parameters, smoothing or something, and then gradient descent will squeeze all of that down. So really, it's pretty powerful idea. This dynamic computational graph systems, and so yeah, that's how it went.
Okay. Then we'll move along with the next stage, which is the decision on using, like, I would like to ask about the loss function actually, because loss function have been one of the, in academics, I was in college, we have this set of loss functions that we are taught, like cross entropy loss, MSE, RMSE, and so on and so forth. And in deciding which loss function, it heavily depends on the data set, yes?
It depends on data set, but you know what? Even more on what you want to achieve, right? Because if you want to have model which seldom is very wrong, then sum of squares, it's a good loss function, right? Because it penalizes this big differences.
Yeah, correct.
But that may not be the best function because sometimes your nature of your forecast is that you cannot predict very well. There is some native kind of irregularity. So by using this standard mean square error, it may not be the best choice. And then what you could consider instead is using L1 loss, right? So absolute value. And I think usually most people, I mean, mathematician, in college or whatever, you always hear, and the books, they always talk about sum of squares because it's nice, because you can take derivative and it brings you down. But that's why, all the books talks about that because it's kind of, you can write some theory about it, you can explain stuff about that, so on. But, L1 is possibly better because it can swallow occasional outliers and not about it. So depends on how your system is behaving. And then second thing is that apart from data, whether this is noisy or not, you should also think about what is your kind of business goal, right?
Yep.
In competition, business goal is to win competition.
Yeah. Yeah. Correct.
So if they specify particular loss function, they are saying they will be judged according to this loss function. When then you use this loss function,
Yes.
you're optimizing for what they want, right?
Correct.
So this is answer why I use the loss, because I was trying to align with the
The
competition loss function.
competition itself. Yeah.
But generally, you really can be creative about it. Just think about like you have, for example, what people care about, because like recently in Uber, I was told the average forecast is okay. We really care about occasional problems during holidays, right? So people were saying we don't really care about average error. We only care about outliers, right? So maybe then you could put this sort of second, this sum of squares, or maybe your loss function, you can weight it differently. Maybe you can put higher loss on holidays, for example.
Yep.
Right? Or maybe they tell you that we only care about, I don't know, big cities. We don't care so much about small cities, right? So the percent, you see, if you have big percent, 5% error in big city, maybe business, from the point of view of business, more important than 20% in small city.
Yep.
Right? Maybe. I mean, maybe not, but maybe, right?
Yeah. Yeah.
And then, right? And then your loss function should reflect it, that, this 5% is more important. So percentage error is no good. So you want to have something which is proportional. So the loss function should reflect priorities of business. So don't be just attached to standard loss functions.
Yep.
No.
Yep. So if we want to tailor to a specific line of business, it's better to also consider a custom loss function that aligns with the business itself, as opposed to using the standard loss function, right? Okay, that's very interesting. And actually, I wanted to talk a lot more on the production side, like in the real life scenario in using forecasting. So one of the questions that I've been asking myself since I was in college was that in production, we see how Google actually tries is able to, for example, Google is able to kind of like learn continuously. The model is able to learn continuously. In this SIEM, there are some tools such as AutoML or other tools that is able to it is supposed to learn continuously. And I've heard that also some model they try to retrain the model fully from all the data set, which for me, in my point of view, it doesn't make sense, because some model actually requires like 2-3 training days, even with strong computers, depending on the size of the data set. And I would like to actually ask, what do you think is the best method to perform this continuous learning in a model?
Yeah, well, I mean, unfortunately, I have to say it depends.
It depends.
But I think I would approach it from the point of view, again, of business cycle, right?
Yep.
Let's say, practically, right? You want to, how the business changes, right? Does the business, if you have very little data, then probably need to retrain more. But let's say you have 2-3 years of data. And let's say it is not crazy times like this COVID, but normal times, right? So when you have normal times and you have more than 1 year of data, then probably, business will not dramatically change between January and February. Or between first week and second week of the year. So it doesn't make sense to retrain it from scratch.
Yep.
Because there is not much new to learn. You just can feed it new data, but the same model, right? So if business doesn't change, you can opt to retrain from scratch, but once a quarter or once a 2 months. And if it failed retraining, you do not panic. You do it again. You may have 1 week delay or something, putting back to production new model. So what? So your old model is working. So the point is, business doesn't change much. You don't need to change model very frequently.
I see. So, but are there like I'm thinking about it in the sense of scalability. For example, if we have accumulated a lot of data and we want to keep the certain good features of our latest production model, um, are there ways to actually fit in only the new data and tailor the hyperparameters, or do fine-tuning surrounds that particular new data and keep the features from the old data?
Yeah, so I guess you want to say, can I, based on my current model, train it a little bit with new data? Right?
Yes, correct.
And definitely you can. The only problem is, um, you cannot do it too little, you cannot do it too much,
Yep.
because if you train it too much, it will pay too much attention. If
Yes.
you train it too little, it will not move much. So it's a little bit tricky to learn what is sweet spot, how much this new data exposure is good. But potentially, yes, you can do it. You can play with that. You can, in backtesting, you can pretend, you're 1 year ago, you can pretend, you just feed it, new 1 month data, right? And then see how it performs in February, right? You give it January, just retrain on, not retrain, but fine tune on January, right? You train just on January data, and you give it, and then you train it and then you test on February and see, compare it to fully retrained model. So you can kind of learn in your particular situation what is this optimal spot.
Yep.
Once you learn it, then in future you can use it without much testing. Right? So it's possible. It's possible. People think about that. Yeah,
Yeah. Because if I think about it, if I use only the new data and I train it over certain epoch or iterations, for example, sometimes there is this sense of being afraid of it being overfit, right, to the new data. So
yeah.
we still employ some form of optimization of hyperparameters algorithms, such as a genetic algorithm, or yeah, I would like to know more about how it works on retraining over this locus of new data.
So wait, if it's neural network, you load your model, and then you train a little bit on new data, right?
Yep.
Which in case of LSTMs probably means you start you have to few steps, warm-up steps,
Yep.
before you come to new data. Now you train it, and that's it, right? So you start maybe 8 weeks ago, you train the last 4 weeks. So I'm saying it's doable for neural networks. For genetic algorithms, of course, it's also doable.
Oh, I mean, using genetic algorithm to optimize the hyperparameters.
Okay.
Neural
So, I mean, you can play with that. It is quite interesting, sexy. Yes, you can do that. Yeah.
yeah, because if you're trying
I
to
mean,
do,
I have soft spot for genetic algorithm, genetic programming. It's just quite often, unfortunately, it's impractical, but it's very good algorithm.
because if I imagine it like trying to experiment or computationally determine the hyperparameters, it will take quite a while to try out all the options, right?
Okay, so but there are two issues here. One is generally hyperparameters, right? So you have 10 hyperparameters as your model of your neural network. So then you can try to use genetic algorithms. You can try to use Bayesian optimization. There are packages for Bayesian optimization, right? But if you just talk about retraining, then you shouldn't change much this hyperparameter. The only thing is how much exposure I give my model to new data. That's the only part. So there's not too many, so I'm saying you can kind of manually try it in backtesting and find out optimal spot. I give 10%, 10% of epoch, I don't know, 2 epochs extra for the last 4 weeks or something. So you can establish it by experimenting without machinery of genetic algorithms or Bayesian statistics. So these guys are more applicable to doing from scratch, I would say.
Yeah, that's interesting. Okay, so I actually that gave me a lot of insights regarding the retraining part. So next, I would like to actually hop a little bit to the part of creating a model, right? So I've read in your entry, you created three different architectures for three different time periods. So there's the weekly, monthly, and yearly architecture model.
By the way, sorry to stop you, but I just want to say before I forgot, you seem to be showing my blog from Uber, which
Yep,
describes
yep.
the stuff, and that's fine. But in January there was a special edition of International Journal of Forecasting, and the special edition, is M4, International Journal of Forecasting. And this, normally you have to pay because to be a member of ISF to have access, but this special edition is free. So, our hybrid method. You see the second one?
Yes.
So you can as a matter of fact, you can download like 40 papers about M4 competition for free. Professor Makridakis paid for that.
Oh.
So this paper is is supposed to better describe what the blog was saying. I don't know. Yeah. So this is more detailed, more polished version of blog. And as I said, there are a bunch of other papers about M4 competition.
Oh, I see. Yeah, I will surely read that paper. Yeah, it's very interesting. So for different time period and different inputs, so we prepare different model. For example, in our company, we have data about daily sales, weekly sales, monthly sales, and also yearly sales, for example. Um, but in this case, what I would like to ask is regarding the creation of model. Is it better for models? For example, if we were talking about calculus, it's better to have slicing as minuscule as possible to predict the aggregate of that result. Does it also apply for neural network models?
So okay. So generally, I think general approach is to do as little as possible slicing. Yes.
I see.
If you have monster amount of data, you can afford slicing because anyway you will have trouble using all of that. Right. So when I was doing project in Uber for customer value, there's 100 million customers, over 100 million. So we were doing it per region because why not? Even 5 million customers is good enough. So you can create separate models, and it makes sense because people say in India, they will spend differently
Yep,
than
yep.
people in USA, right? So if you have monster amount of data, split. But if you don't have monster amount of data, you better have single model, frankly.
I see.
Because that, as long as your neural network, your learning system can swallow that all, then better to have it in one. I was in M4, I was splitting because there were different horizon.
Yes, correct.
You have monthly model, daily model, and hourly model. Nothing to do. Hourly has, this 24 hours, 168 per week seasonality. Surely you have nothing like that for monthly.
Yep.
So it was natural to split it along the frequencies. But generally in business, I would say if your model doesn't choke on it, if you don't have performance issues, if you can read and learn from it, then keep it in one place because you never know. It may be that some city in one country or some, strangely enough, resembles some other place. I remember someone was telling me that they were doing, and they noticed some correlation between some cluster of San Francisco and New York.
Ah, I see, I see.
So you have 3 hours difference, but if you adjust for this 3 hours difference, they were kind of having the same cycle over a week. And then turned out that both are kind of entertainment districts. People go there after work to drink, and this is used to before this COVID, right? So the point is, you could learn on subset of San Francisco to improve on subset of New York, and if you split them, saying East Coast, West Coast, you wouldn't be able to do it. So as long as you can afford, add additional variables. variable which says this is East Coast. This is, you can inform the system that this is different region, right?
Yeah, yep.
Absolutely, you should do that, but rather keep them together.
I see. Okay, so I was asking also because, for example, in this time period, the Corona period, right? All models are thrown away due to the abnormality of data, and like, how do we as data scientists kind of prepare for that, or are there any ways to prepare for that, or there's no exact way at all?
I don't know how to prepare. I mean, this is a rare situation, right? I mean, something similar happened in 1918 or so. So it's difficult to prepare. It's more like, how do you respond to that situation?
I see.
And in my career, I always look at past time series, right? But if your past is dramatically different, then it's a problem, right?
Yep.
So I remember, you can try, in such situation, I would suggest try to, you can kind of use your model as it was, but try to scale it down, right?
I see.
For example, you can compare, general activity, right? Like, I don't know, general production activity, or to have some correlation between number of beds occupied in hospitals, or how many cars are traveling on the road. So normally we have 2,000 cars crossing this highway, but now suddenly it's 1,500, right? So you can try to. This transportation is kind of good, maybe good indicator, So you say, we scale down our models, and then you watch this economic index, how it behaves. If you start creeping up, maybe you can attach yourself back to, start multiplying it by this general activity index. So yes, your model train it up to March. You can still use it, but scale it down, right? I mean, it's far from best. It's far from best, but maybe it's right. In longer term, you can try to retrain it and see how it goes, but that requires, I don't know, at least 6 months, 12 months.
Yeah, that's why I was wondering, because as data scientists, like during this kind of period, like what are the what due to the lack of data set that we have, it seems like any model doesn't fit very well with the current situation.
No, it is generally a problem, because I mean, modeling, prediction can be done by by looking back in time, right?
Yeah.
So you assume that the patterns in his past patterns will repeat themselves. But if the situation is dramatically different, then there is no reason to assume that the model will be good enough. All these machine learning models we have currently, they don't have much intelligence, frankly. They just fit pattern from the past. So if the current situation resembles past, they will kind of find similar, and the output prediction, right? They don't have common sense. So
Yeah.
so if the model was trained always on growing data and you suddenly show it drop, that thing can get crazy, really, because it has never seen this part, right?
Yep. So it relates to actually one of Mr. Jing's questions. So, but there are some way possible to connect external data that capture the may capture the situation through external data, such as what you're saying, the economic index and number of beds in hospitals and so on and so forth. So even for the prediction for internal data, it's also possible to add external data source as an indicator, or yeah, something like that.
Possible, but you have to have it, right? If you have 3 years of data, then this indicator should also be 3-year old. I mean, you should have it every moment of 3 years.
Oh yeah.
So that's why it's usually a problem if your data is 3 years old but indicator is 6 months, then it's a problem, right?
Yes.
Because otherwise, absolutely, you can add it
Yep.
and see how it responds.
So what's important is the pipelining between the external data to fit to our internal data.
Yeah, you just pre-process and so
Yes,
on.
the pre-processing part.
It's this trick is also useful if you have very little data and you need to have long forecasting horizon, right?
Yep.
So let's say you have 15 months of data and the boss says what we will be doing in 5 years, right? So this is sort of impossible to
Yes.
do, but what you can do, you can kind of train your model on this 13 months, do some prediction, but then kind of scale by the model,
Yeah.
which uses
Extrapolate the.
activity on network utilization, the internet network utilization in your country. This is some sort of, usually people have this data and it's very long, 20 years of data or something. So you have something which is long running, easily accessible, stock market indicator, economic growth indicator,
Yeah.
network utilization, internet. And you can then try, so your model does some sort of seasonality, not much, but a bit seasonality, and then you kind of multiply it by this long-term model.
Yeah, that makes sense.
These kind of things, Yeah.
Yes, that actually makes a lot of sense. Yeah. Finally, maybe the last question from me is actually the about explaining the model results, especially in neural networks, since it's a black box, right? Um, Actually, there are some ways that I use in my thesis, in particular, to explain the models, such as Lime. Um, uh, are you familiar with Lime, Mr. Sławek? Yeah.
A bit, yeah.
Yeah. So from what I know, companies here in Indonesia actually use Lime a lot in the past recent years since its creation, in I think 2017 or so. And what about Lime? What do you think about Lime? Are there any extension to the usage of Lime, or
See,
what's the right
so
now?
I am aware this package exists. I read documentation. I maybe run it once, but I'm surely not proficient user of it. But general idea, I think is correct.
Yes,
You try
correct.
to see, how the model responds in vicinity of your area of interest, because they are nonlinear, right? So
Yep.
you can, but you say when we are around here, if I perturb this parameter, the output will go out, down or up or something, right? So I think it's on the other hand, if the input is like that, as it was 2.5 years ago, situation was different. If I perturb the same parameter, model responds differently. So you can kind of create story, like
Yeah.
you can, in this scenario, change 2% here, will have this response. In this scenario, change 2% here with that response. And if you presented the scenarios, the business people like to hear this kind of
Yeah. Right.
scenarios. And yeah.
So what's the choice that you use to explain the story behind the decision of your model?
So frankly, I avoid it as much as I can. So I'm saying I know Lime, and I think that the idea is reasonable. Doesn't mean that I happily do that. I only do it in if I'm forced to do, and I avoid as much as I can doing that, because frankly, I believe it's for. I mean, okay, it has some sort of reasonable reason, but on the other hand, when people make decision, whether business people, people make decision about something. How do you know what sits in their head? I mean, they say, the big boss says we are closing the operation or investing 5 million here or something. Why did he do that? He took some input from he uses his home experience, maybe some advisor or something. But the point is, you never know. You cannot explain in terms of neurons or final points of decision making why he made the decision. His black box, his head is
Yes.
black box,
Yeah.
right? So really, we live in the world where people making decisions, and we cannot completely explain these decisions. So why should we be able to completely explain decisions in neural network? I mean,
Yeah, because like people that I have to explain my model to, for example, or my prediction to, they're perhaps not they don't understand the
I know. Yeah,
relation
I
there.
know.
How do we actually explain that kind of stuff?
So I'm a bit pessimistic here. One approach you can take is that you have your, which I would do, frankly, although it's suspicious, but I would still do that. So you have your black box neural network or something like that, or random forest or something, and you train it, you fine tune it, you find best parameters, and then you get you do proper back testing,
Yep.
and this is my best model, right? Good. That thing runs, that some does prediction of something, and then people say, oh, but why, right? And then you write second model, something like linear or some very, very simple random forest or single
Yep.
tree model.
Decision tree. Yep.
Right. And quite often you will find that very, very simple model, like 1-2 level tree, which still can be sort of understood, is doing 80%, 85% correct as your sophisticated model.
I see.
So now you have your sophisticated model, which says, forecast 1605, your simple model says 15.7, and then you explain mechanics of the 16. The simple model.
I see.
So you create understandable models to create story for
Yep.
bosses.
Yep. Yep.
While in reality, you have a real model doing this.
Yeah. That's really interesting. So you try to explain using an understandable model and show the result wise, right? As opposed to a way to actually create a story like a Lime will do. Actually, okay, that's really interesting. Yeah, yeah, I can totally
I mean,
understand.
it's alternative, right? And I think it's good alternative. And also think about it. Generally, think about it. Frankly, quite often, you see that the simple model really does 85% what your
Yes,
best model, right?
correct.
And then it's really a question. Sometimes it's crucial. Sometimes it's really important to have as good forecast as you can, right?
Yeah, like proof of concept.
Really best. But sometimes, like I heard sometimes in Uber, people say, well, this forecast is already good, so what? If you squeeze it from 16 to 14, who gives a damn? Because our decision makers, they only care if something is suddenly above 50% or something.
Yeah, I see.
So if you have this situation, people are not crazy about squeezing the last ounce of performance, maybe really use simple models.
I see.
Don't bother about sophisticated models because they are black hole of time and effort, especially neural network. Neural network takes horrendous amount of time to get
Yeah.
anything, right? So instead of those simple random forests, which requires very little data preparation,
Yep.
perform pretty well, or XGBoost or something like that, create simple model. You do it in 10% of time as doing, good neural network model. Yep. And then you can even simplify it to, very simple random forest to be explainable. And maybe you can stick to that. And then you don't need to even cheat, you really just use simple model and people are happy. So,
Yeah. I totally get that. Yeah. So yeah, maybe that's the questions that I have. But I believe Mr. Jing has other questions. If you would say.
Yes, sir. Actually, that was exactly the a really good segue, I think, Vidi, into my question. And my question was Mr. Slavik, that I saw the theme is around complexity forecasting models, and we had spoken previously with Ritesh, and also I noticed Francisca had this diagram here where she, I think, complemented your solution because it was, I believe your solution was Theta, correct? And she said that the solution was actually better than a lot of other machine learning methods because it was simpler and it resulted in more efficiencies. Coming
Yeah,
from
yeah. So I tell you the story behind it. So yeah. So the theta method, it's extremely simple. It's ridiculously simple, and strangely enough, works pretty well in most cases. So this is basically linear regression, and then you don't continue the slope by you move it sort of halfway down, and that's it. So, and that's your forecast, and that simple algorithm kind of doesn't make sense, and yet it performs at the level of exponential smoothing in ARIMA, and that quite often, and requires milliseconds to fit in comparing to seconds for ARIMA and sub-second for Holt-Winters, right? So when I came to Uber, I started pushing for using Theta because they needed. You see, there were some cases. Engineering in Uber, there are literally hundreds, thousands of time series coming from all over the world, various stuff, like number of credit card transactions, the number of sessions, how many people clicked on that, how many people, do something. There are heaps of stuff coming. And the engineers need to know whether a particular situation is normal or abnormal, right? So whether suddenly, drop of transactions, does it mean that something screwed up in the system and they need to rush to try to understand what failed? Or is it just normal because it's middle of night, not middle 4 a.m. or something, and there's not much activity, right? So there is a massive amount of forecast needs to be done very quickly, like that, and then simple algorithm which works in milliseconds is perfect. It's not perfect. I mean, it may have error of 15 and Holt-Winters 14 and ARIMA 14 and and XGBoost 12, and I maybe squeeze it to 11 through neural network, but so what? The point is you can do hundreds of them per second.
Yep.
And you get rough estimate because you will raise a lot if reality is 3 times bigger or smaller than what you predicted, right? So for purposes like anomaly detection, something is screwed up or something is going normal, fast algorithm may be important if you have huge amount of time series, right? So it depends what you need. If you need large amounts, simple algorithm, good. You don't have hardware resources, and frankly, no one cares because they are not looking difference between 12 and 14. They're looking difference between 1 and 100, right?
Yeah.
Big ranges are raising alert. If something is 14 and it's 21, so what? So maybe there is some wedding party or something. Right?
Okay.
So you only looking for big shifts.
Okay.
That's why then fast algorithm is good algorithm.
Got it. Okay, that actually is quite insightful, and I do see that depending upon the business case, there are lightweight algorithms that actually are more effective than heavyweight that could. It's okay. No, completely understand. It's like okay. Let's go. I guess we had touched upon this before, Mr. Sławek, but in regards to forecasting, how it's crucial for our company is that our business model is based on this. A lot of short-term rental companies they essentially pay an owner first, lease arbitrage. So they pay an owner first, and then they retain rights to lease the property out to travelers or such. But we don't do that here. What our way of getting properties is very dependent on creating a very accurate forecast for that property over a 12-month period. So what we try to do is we look at properties we have in a certain area. We then take on a new property in that area, and we try to give the new property a forecast based on historical data that we've accumulated about the region, about average daily sale prices, time series of transactions, so that the new property can get an accurate forecast. So my question is related in data diversity versus data focus. I noticed at Uber, most of what you're using to actually create these forecasts is data inside Uber. It's like the driver patterns, the time series from the thing. But is it ever necessary or advisable to input external data sources like maybe Uber doesn't have weather, so you'll get weather patterns, or I don't know, the stock market prices, or the economy, or things like that. Would you ever consider it advisable to add external sources of data that you, in order to get a more accurate result, or is that unnecessary in your opinion for a revenue forecast?
So no, kind of in theory, it is a good idea, but you have to look at details. For example, weather, right? In practice, like we were trying to add weather to our forecast, but you need to really add forecast of weather, right? The point is, good forecast of weather is sort of believable for 8 days, right? So therefore, if your forecasting is next week, then it can be pretty useful addition to your input. But it needs to be forecast, and the companies we've been checking, they don't store a past forecast. They only store a current forecast and past real data, past real weather. So you see, if you want to train your model, you actually don't have data. You need to store it. If you want to use forecasts, you need to start storing them now to be and diligently store them. And in 2 years' time, you can start building model which uses forecasts. Because unfortunately, as I told you, I don't know, maybe in Indonesia you have better, but in our case, we couldn't find provider which was storing forecasts. They were only storing reality, past history. Now, reality, on the other hand, could be occasionally useful, but then very short term, like, if it's very cold in New York today, probably will be also very cold tomorrow. But, this is even shorter, right? So we are not talking forecast, we are now talking like 1 to 3 days. So on one hand, very short, 1 to 3 days. On the other hand, when I was doing this GAFCOM, Global Energy Forecasting Competition, I found that actually current weather can be predictive in middle term, meaning like several, like quarter or something. So it turns out that if you have hot summer, usually you have cold winter, and other way around, this sort of things. Okay. So current weather. So if you have this few months ahead horizon, current weather still can be useful, but you have to try it, and so either very short or longer, a few months ahead, current weather useful. Otherwise, you need to have forecast, and you probably don't have historical data.
Okay. What I don't know.
And so I saw generally about weather, right? And generally, frankly, the same pattern appears in many other cases. Stock market, yes, you can have it, but many other time series you would like to have it. Actually, they don't have good history look back. The data is dirty, missing. Some cities there, another cities not there. So there's a problem of quality, and how good the historical data is. Someone has to spend effort to diligently collect it, clean it for a few years before you can use it. And unfortunately, it seldom happens.
Okay. Mr. Slawek, my question, if I could refine it a little bit, was in the context of, let's say, predicting revenue. In the context of predicting, let's say, revenue, how much, like, how many variables would you think that are necessary? Is it like what you said, that like if you can get, like, just say a simple set of data, you can get pretty much a very good result, or does it start getting, do like, okay, I'll give you an example. So we're trying to predict revenue now based on, let's say, a multitude of amenity functions, or a multitude of amenity variables around a property. Does it have a swimming pool? How many bedrooms it has? Maybe what the color of the kitchen tile is. But for me, I would say maybe the most simplest way to predict the revenue of a given property is to look at the sales data for that property and then extrapolate that into the future. What is
Okay,
what is your opinion on it? Is it adding more variables, or is it just sticking with a few of the most important variables will lead to the best results?
So definitely, if you have good data, add it, try it. It may be useful.
Okay.
On the other hand, if you have time series based algorithm, you will often find that so you encode the past history in somehow, and then you add also these features, garage, I don't know, beautiful bedroom or something. So you stuff that thing together, and it's good. It really doesn't hurt, I mean, unless there are thousands of them. But if you have dozen extra variables, good, add them. The point is, if you the good time series algorithm will usually be able to extract pretty much everything from the time series. And because if it's good property, if it's attractive property by something, then the time series will be growing or will be higher. If it's crappy property, will be lower and not growing so much. So these additional variables are kind of already encoded in the history, right? These variables are especially useful if you don't have much history, right? So if you have new property, so you have, and then you have all this set of variables, but you only have 1 month or 0 month history for this property, then they will be very, very useful. If you have, however, 2-3 years history, it probably will be less useful.
Got it. Okay,
so this is called a cold start problem, right? These guys are very useful for beginning. Very useful for beginning.
Understood. Okay, very good. I have actually a data persuasion question, which was one of the things that I think we alluded to just previously, which is this is not just your boss. This is like kind of maybe your boss's boss. These are the clients eventually. So in a case where, let's say Uber, you're using dynamic pricing to create liquidity in a marketplace, and you're using a system such as surge pricing, um, you get pushback from the community because they feel like it's not a good system because for whatever reason the feeling is different from what the actual good business practice is. We as data scientists can look at the data and we can objectively decide this is a good system, this is beneficial to both drivers and riders, but sometimes we have a hard time persuading others of that idea. Have you, and I've noticed that Uber before, there was this data psychology maybe. I remember reading a blog, and Uber uses, like, let's say, leaderboards to sort of rank productivity of team members and such. Have you noticed these kinds of frictions in getting data to be understood or to be persuasive? And I heard the little trick that we used earlier about using the simple model and explaining to your bosses about the simple model. But at also a global level. Oh, sorry, Andre. We're going to use this channel for now for the professional networking. Okay, thank you. Have you noticed that there's any sort of data persuasion techniques that are pretty effective in your career?
So, so this is a bit different because what we were talking before was, persuading your boss, maybe, who is already business understands, although he's not data scientist.
Right.
So now we are talking about persuading public about something. That's quite different, and I don't think I don't think that data scientist is not necessarily better. Average data scientist is not necessarily better positioned to persuade public than anyone. I mean, taxi driver may have better idea how to persuade public than your master degree, because he talks to more people. He sees how they react. He's not sitting in algorithms, but talking to real people on the street. So, in Uber, I know that it's for quite some time. There was a special team called behavioral science, and there was a bunch of people from things like psychology, and they were and they were trying to do this kind of stuff, trying to understand, for example, cluster customers, right? So they would say that, and sometimes it was pretty clever, sometimes a bit fishy, but sometimes it was clever, They were, for example, saying that average iPhone user is different psychologically than Android user. So when we send promotion, they should be phrased differently for these two groups of people, So I'm saying, yeah, either you have to talk to someone who has good grounding, steps on the ground, and knows what people really want. And I don't think that data scientists are particularly good at that. I am definitely hopeless. Or you can get, or you can try to get really help from psychologists, for people who are professionally supposed to be good at that, and they may be helpful.
Have you ever seen, like, say, data requests by the behavioral psychologists to sort of support their campaigns? Like, if they do interface with data scientists, are there any sort of like, oh, could you show us a comparison of this and this, or like have they ever requested any information on your part?
No. There was some talk. I will help them. I remember I kind of informally asked them, "Oh, why do you use this sort of linear regression? Why not tree-based model?" And they were saying, "Yeah, we will improve." So, but I didn't have much interaction with them. I just attended a few presentations, and I believe they were doing a good job. But I don't know. I'm not sure.
Okay, understood. And
So,
okay, just one last question before I think it's almost the full hour now. So we have essentially a, I'm not sure at Uber, but on a platform like Airbnb where I previously worked, we saw that there was a long tail distribution of influence in a marketplace versus the person, the influencer. So you would see, let's say, a small number of very, very successful hosts, and they did something around maybe 20 to 30 to 40% of the entire business in the entire marketplace. I think this concept is pretty common, like on YouTube, Instagram, you have an influencer and they have like a wide segment of audience. Um, we effectively do that on Airbnb. So in the particular market of Bali, I believe we do something around 20 to 30% of the overall business in the entire market space. My question is related to, at what point does like the data, how much of our data reflects the total amount of data that's seen across the market? Like, in your experience, let's say growing Uber and watching the data accumulate, at what point, let's say, were you able to see like, oh my God, like what we see in the data now is pretty much the same picture and we can get the same insights as what we did when we were 4 times smaller? Like, is there a point where the data just becomes the same, or is it like the more data you have, the more insight you're able to see? And is there a point of diminishing return where more data doesn't necessarily mean any more insights after a certain point?
so definitely there is diminishing return, and it again depends on business. If you have fast-growing business, 5-year-old data is useless because it doesn't reflect at all current reality. So in these circumstances, I had informal rule of thumb that I cut off anything more than 3 years. So, 3 data was the last 36 months. That's it. If I had more data, I wouldn't use it because it's fast growing business. If it's something stable like airline business, well, before this bloody COVID, then we can use much more because it's stable business. You can use 8 years or something because they are growing nicely every year, little bit, but they are nicely seasonal and slowly growing. But something like Uber or I guess your business, you either will be very successful in 3 years or not existing or something. So the point is, it doesn't make sense. The data with more than a few year old probably is useless.
And is data quantity after a certain size also useless, or is like like at what point do you not see insight anymore? Like when you go from, let's say, 5 million users to 15 million users, do you start seeing like new behaviors that you could not predict before, or is it simply just scaling? Like it's just the same behavior, but 3 times bigger now.
So, generally, if it's machine learning algorithm, the more data, the merrier.
Hmm.
But yes, there is a situation where your algorithm start choking on the amount of data. And then, like random forest, if you dump on it few million, records, then you have trouble. So it will go nicely with 100K if you have 20 times more, not really, right? So there is practical thing that your algorithm may have some threshold before it's having trouble. Neural network are better, they can swallow more, but still there are some limits, right? And in these circumstances, you just need to decide to either split it into subregions, as we were talking about,
Yeah.
or maybe I mentioned this CV project we were doing. So this customer value. So we were not only split into subregions, but frankly, we're also sampling. So you can train your data on random pieces of the whole data set. And you will find out that at some stage, training anymore doesn't help anymore. So like this performance and validation will plateau and start going down. So it means that, in practical days, there is limit. At some stage, your algorithm will not benefit of training more, even if you have more data. Even if it can swallow and process it, you will find out that it's not really much improving anymore. So then it's time to do sample. You sample. You can train 10 models, each of them separately doing sampling, and then you put it together and sample, and then it's good.
I see.
And then each of them can be trained on 5% of data,
Mm-hmm.
and then 10 of them, and they will have very strong performance, even if none of them saw more than 5% of data.
Got it. Okay. Let's say this would if we have 5% of the data, but we believe that we have a random sampling of 5% of the data in the overall data set, could we then extrapolate our models to the entire market?
But you randomly sample. Assumption is you sample well, right? So I'm saying you have 100%. You sample randomly 5%.
Mm-hmm.
You train in one model. You randomly sample another 5%. Train another model. You continue. So that means that there is no reason to believe that each model will know everything. But on the other hand, few of them together will be pretty strong. So they won't, because you sample, and if you are afraid that you will skip something, you can force sampling to be like guarantee 10% from this region, guarantee 10% from this region, guarantee 10% from that, right? So you can do this stratified sampling to force it to be kind of fair, but still sample, 1% of each regions, and then you can get it.
Okay. So just really quickly, would it be foolish to assume if we say we had 20% of all the overall bookings in the entire market, would it be foolish to assume that that 20% is a random sample of the overall market?
That would be a bit dangerous, yes.
Okay.
Because you can sample well your data, but your company differs from, so it's a bit dangerous. Yes,
Okay. Got it.
yes.
Understood. Okay. Back to Vidi, actually. Thank you for the time.
Yep. Thank you very much, Mr. Jing. So I will go through Karian first. Are there any particular questions?
No, so far I don't have any questions
So
for that. So, yeah, thank you for asking.
Yep. What about Lilis? Any questions from Mr. Sławek?
Yeah, actually, my question is already delivered by Jing. It's regarding the worst study factors that where we want to make the forecasting, and also a little bit about actually customer behavior. I see that when Ubers make forecasting, for example, is there any influence from the customer behavior to forecast the right pricing and also the right drivers to match on it. Is there any influence of that, sir? Maybe that's the additional question.
So, in forecasting, frankly, we were talking about we've never done it. But what I tell you is that Uber is constantly experimenting. So some people, pretty much, you may not realize, but like there are like few thousand versions of Uber app concurrently. There are small modifications here and there, and almost no one has the same app. And then there are this A/B testing. Did people were less patient? Did it click here or not? So there are constantly experiments, and then you kind of can learn about people. What they like, what they don't like, when they give up. So in this way, customer feedback was incorporated by experimentation, by making better business practices. But frankly, I didn't use it for forecasting.
Oh, yeah. I see that because we also in the development of application that used by client actually, sir. So, yeah, maybe we just, asking for that insight. Thank you very much, sir. That's all, VD. Thank
All
you.
right. Okay. Maybe that's it for the questions, Mr. Sławek. And as the moderator, it's done from me. Maybe I'll give it back to my boss, Mr. Jing.
Okay. All right. Thank you very much, Vidi. Mr. Slavik, we would like to actually move into the next part, which we will post on our LinkedIn a thank you and a recognition for your expertise, and also to commend you. And we'll ask the team to also engage on the post. So what I'll do now is I'll just take a quick screenshot, Mr. Slavik, and perhaps if you can give a thumbs up or something, and then we can go with that. Okay, ready? 1, 2, and 3. Okay, done. Okay, cool. And once again, I think we all learned so much today, and I personally feel like data science is it's something that there's a lot of misconceptions about, and actually talking with real data scientists, we've been able to definitely make progress on getting to base reality. So I want to say thank you for that. And I want to also make our hospitality services available for you and your family should you ever decide to come to Bali. We'll be very happy to host you in any of our accommodations. We have about 180 properties now in Bali. So please don't be a stranger and let us know before you arrive.
You can give me some discount, right?
I can probably arrange a free stay in one of our properties for you. Sorry. I can.
Well, that's
I can
yeah. But is it possible? This COVID. Is it like you have this still quarantine? You can.
Not now, but we've heard that in July
Yeah,
we're supposed to
actually,
over to Vidi.
like flights are coming in on October in Bali.
Oh, really?
Yes,
So it is true. Okay.
that's the plan,
Okay.
at least.
So
You said October.
yeah, starting from October. But I think, Mr. Slavik, you have a lifetime pass here. So whenever you want, just notify us, and we'll make it.
Thank you. Bali. I live several years in Australia and never visit Bali, so I hope one day I will. Indonesia, maybe too. I mean, I've been a few times in Thailand, so maybe eventually, after revisiting Thailand, I can maybe visit Indonesia.
It's similar. I would say that my trips to Bali and Thailand were very compatible in terms of the experiences that you can get. Bali tends to be a little bit more compact. You can kind of engage in all the, like Thailand, you'd have to go to the north to see the rainforest, the south to see the beaches, and the center to see the urban life. In Bali, on one island, you have the entire range in one place. So that part makes it very cool. And there's just so much. I think there's more diverse experiences here now than Thailand. So yeah. Did you happen, Mr. Slavik, to know this former data scientist? His name was Lance Martin. He went on to work on, I think, the self-driving trucks that Uber was working on when Otto, I think, was acquired by Uber.
So I don't know.
Okay.
Yeah, and what happened?
Okay.
Yeah.
So Lance happened to be one of my guests, and we this is how I first became. very fascinated with the idea of data science at Uber. And Lance also spoke about times when he would go to Travis's house and they would jam about data science, and it seemed like it was a very strong culture of just sharing knowledge and such. So
it was. I'm afraid things got worse in Uber. I mean, from my point of view. You know, when Kalanick was boss, things were rougher, but kind of moving in the right direction. And now people are all soft and politically correct, whatever. But the results are, not so good. So
it's a shame. I think Uber should have been in New York maybe rather than San Francisco.
Anyway, you know that I am laid off from Uber, right?
No, I did not know that, sir.
Well, tomorrow will be first month. So yeah, the last month they told, thank you very much for your services, and I get laid off. So I'm now, I'm interviewing and so on. So Uber is past, but
I did not know that.
Most of the time was good in Uber. It just last few months particularly bad.
I feel you, sir. I feel you.
I'm shocked. I'm actually quite shocked because I'm what you're doing is so fundamental. I think to the
it should be, frankly, but I think it's the short-sightedness. They say, for the next few months, this forecast will be useless, and that may be true, frankly. but firing me without exaggeration, I'm the best forecaster in Uber, definitely.
You're the best forecaster in the world.
So it's a bit stupid. I mean, admittedly, not just me. That was 2000.